In this problem, we are going to try to calculate the slope that's being created by a ladder that's leaning against the wall. We're given a couple pieces of information here. We're told that the height of the wall is 15 feet, and we're told that from the base of the ladder to the wall is 3 horizontal feet. So we want to know, if we lean this ladder against a 15-foot wall 3 feet away from the wall, what's the slope that's created by the line of the ladder? So we don't know what that is, but let's call it m. In mathematics, I always tell my students to use what you know to find what you don't know. What we don't know is the slope. However, what we do know is that to calculate the slope is the ratio between the rise over the run. So in this particular problem, we have the rise and we have the run. The rise is the 15 feet, so let's go ahead and substitute. The run is the 3 feet, we'll substitute. And we don't know what m is, so let's go ahead and bring it down. Now we can see that m is equal to 15 over 3, which simplifies down to 5 foot per foot, which is the slope of the ladder. In this next example, we are going to also use the relationship between the slope, but this time we're going to calculate the height of the wall, which is missing. So we want to know if the ladder is still 3 feet away from the wall, and we know that the slope that's being created by the ladder is 2.5. How can we use that piece of information to figure out what the height of the wall is? Since we don't know what the height of the wall is, let's just call it something. I'm going to call it x. And we're going to try and figure out what x is. So again, use what you know to find what you don't know. We know that the slope is equal to the rise divided by the run. And we know what the slope is, so let's go ahead and substitute. That's 2.5. And we know that the run is 3 feet. We don't know what the rise is. We called it x. And now you can see that we have an algebraic equation where we can use inverse operations to solve. So to solve for x, we're going to multiply both sides by 3. This will cancel out on the right-hand side. And on the left-hand side, 3 times 2.5, we get 7.5. Let me change my color here. So this tells us that the height of the wall is 7.5 feet. Let's take a look at the last example. In this example, they also give us the slope of the ladder. The slope is 1.75, but this time we're told that the top of the ladder is 9 vertical feet, and we're being asked, if that's the case, what is the horizontal distance from the base of the ladder to the wall? So let's go ahead and write down what we have. We know that the wall is 9 feet, and we know that the slope is 1.75, and we want to know what the horizontal distance is. Again, we don't know what it is, so let's just call it something. Let's call it x, and we'll go back and look for it. Again, just like before, use what you know to find what you don't know. We know that the slope is equal to the rise over the run, and just like before, we're going to substitute what we have to find what we don't have. So again, we know that the slope is 1.75, so let's go ahead and substitute that. The rise is 9, and the run, we don't know what it is, we're going to call it x. Again, let's use inverse operations to solve for x. So in this problem, notice that x is in the denominator, and I want to solve and get x by itself. So the inverse operation here would be to multiply both sides by x. It's going to cancel out on the right-hand side here. On the left-hand side, we are left with 1.75 times x is equal to 9. And then the last step is to divide both sides by 1.75. This will cancel out on the left-hand side. And if we divide 9 by 1.75, round it out about 2 decimal places, that's approximately 5.14 feet. So that's the distance, the horizontal distance.